All right, good morning, scholars. Last night when I made the video for 13-5, I realized I could not do all the examples in one video. So sorry, this is a day when I would have been teaching bell to bell. So here's part 2 of our lesson 13-5, the law of signs. I need to do 3 more examples for you. So the first one I want to do, and all of these, well, the first 2 examples I'm going to do are all what to do when you have the situation where you have a side, and an angle. If you notice, if you write that backwards, it spells a bad word, so you'll always know when this situation is going to happen because you've got side, angle, and that spells a bad word. So when you have that situation, you have to look at all the possibilities. You have to look to see, is it possible that I don't even have the long enough side to make a triangle? Or is it possible that I have just the right side to make one right triangle? Or is it possible that I have a side that's going to form 2 potential triangles? Or is the side so long that there's only one way that it can fit? So that's what's on page 800 in your book, the chart that shows the 4 different possibilities when you have an acute angle and you're trying to figure out what triangle is formed. So it's usually not a word problem, because if it was a word problem, you would know whether it was 1 triangle, no triangle, or 2 triangles. But it's just given information. So the first example I'm going to do for you would be when you were given the following information. I'll just go up here and put the information in my little chart that I already drew. Let's say that they told you that angle C was 63 degrees, and they told you that side B was 11, and they told you that side C was 8. All right, do you see it? Do you see the angle, side that spells the bad word? When that's your situation, when you have an angle and you have the side across from that angle and then you have another side, you have this situation. So when I have this situation, I always set up my triangle this way. I draw a base for the triangle, and I don't know how long that side's going to be. That's the unknown side, one of the unknown side, or the unknown side. And then I put the angle that's given to me in the corner, right over here on the left. Just to be consistent, I set it up the same way every time. So I put the 63 degrees, in this case, C here, which means that I put the 8 across from it. That's going to go over here, and I always draw it like I'm not sure if it's going to be long enough to reach. And then the other side that I have is side B. I always put that right next to the angle that I've been given, so I put that right here. So that means this is going to be A, and somewhere over here is going to be B. So I don't know exactly what's happening yet, but that's the given information. So the question is, does this side, the side that is length 8, is it long enough to make a triangle here? Or is it just the right length that it would fit right here? Or is it just the right length that it would go here and here? Or is it so long, that it's going to come over here and it's going to sit over here on the side? So we've got all these different possibilities. So the question really is, how long is 8? It's definitely longer than the side that we were given here, side 11. But is it long enough to reach way over there where I have the letter B written? So the thing that we want to figure out is we want to figure out how long this is right here, because that's going to be kind of the determining factor. And so that's going to be our unknown side first. We're first going to figure out how big x is. So x is part of a triangle that is a right triangle that has 63 degrees here and 11 here. So let's figure out how long x is. We would set up the sine ratio, and we would say sine of 63 degrees equals x over 11. And then we would get out our calculators. We would multiply both sides by 11. And we would figure out that side x, 11 times the sine of 63. Always make sure your calculator's in radians. Side x would be 9.8. So the side that we have, the side that is 8, is not even long enough to reach straight down and form a triangle. So this is an impossible situation. There is no triangle possible. And that is because our side, our given side, was shorter than the other side times the sine of the angle that was given. And so this right here, when we figured out that x was 9.8 and we compared it to our side that was given, because our side was shorter than 9.8, it's not even possible to make a triangle. So that's going to happen in one of your homework problems. It's going to be too short to make a triangle. Okay, now the next example is where it's going to be just the right length to form it's going to be just the right length to form two triangles. So let me show you how that one works. That's the one that's kind of crazy. So again, I would always set it up like this. A, B, C, A, B, and C. And let's use this example right here. Let's say A is 23, B is 14, and B is 33 degrees, angle B. Okay, so we have it again. You can see it again. Angle, side, side spells bad word. So you know this is one of the ones you got to be careful on. So set the triangle up the same way. I always put the angle that's given to me over on the left corner of the triangle. And the side across from it, I leave it kind of hanging there because I'm not exactly sure how it's going to fit. And then I've got the side next to it, so I'm going to call this 23. So this time A is going to be over here because that's across from the side 23, and C is going to be up here. I just set it up the same way every time to make sure that I'm being consistent. All right, so the question is, how long is this right here? How long is that side right there? Because if 14 isn't long enough, we won't be able to make a triangle at all. So the mystery side x would be sine of 33 degrees equals x over 23. Multiply both sides by 23. 23 sine of 33 degrees turns out to be 12.5. Okay, so we're in business. It's longer than the length needed to go straight down. So I can even erase that straight down value right here. I don't even need the x anymore because I know now that this is long enough that it will reach over here. Okay? Now, if it was longer than the other side that was given, then we would put it way out here like that. Okay? But it's not longer than that side. It's just longer than the height of the triangle. And so we're okay to put it right here. Now, the other possibility though, and I'll just draw it as a dotted line for now, is if you swing it in like this, it could sit over there. So the first one that we're going to solve for the way I have it drawn right now, as it is. We're going to solve for this one. Let me switch colors here. We're going to solve for this triangle right here. That's going to be our first and obvious choice. Okay, so we're going to use the law of sines to solve for this. We're going to say, I'll do it in blue since we're doing the blue triangle. We're going to say sine of 33 degrees over 14, that's the angle on the side that we're given, equals the sine of A over 23. Now I had to go with A because I don't know anything at all about C. Angle C, side C, I know nothing. But I do know side A. So I can set up the law of sines and I can cross multiply. So 23 sine of 33 degrees equals 14 sine of A. I'm just cross multiplying. And then to solve for angle A, I divide both sides by 14. And now I have sine of A equals 23 sine of 33 degrees over 14. And how do I solve for angle A? How do I get rid of this sine function right here? You can't divide by sine. You have to undo sine. Sine is not multiplication. Sine is a mathematical function, and to undo it, we take the opposite of it, which is the inverse sine. So I take the inverse sine of both sides. It's going to cancel that out, and angle A is going to be whatever the inverse sine of that monster right there is. So on your calculators, you're going to go inverse sine, which is the second function of the sine, and inside that parentheses, you're going to go 23 sine of 33 degrees, close your parentheses, and divide by 14, and then close that parentheses because you did the inverse sine. It's a lot. All right, when I do that, I got 63.478. So angle A is 63 point, I'm going to say 5. I'm going to round it off to 5 degrees. So we just figured out this angle right here. Angle A is 63.5 degrees. Okay, so that makes it seem like we've solved the triangle. And for the blue one, we're almost there. We still need to figure out angle C and side C. So if you subtract from 180 degrees, you get that angle C is 83.5. I won't bother you with that math. And then you set up the law of sines again. So you're going to do the exact same thing. You're going to say sine of 33 degrees over 14, but this time you're going to say equals sine of angle C, 83.5 divided by side C. And again, cross multiply, divide by the number in front, and then take the inverse sine, and I'm just going to go ahead and tell you that side C turns out to be 25.5 degrees. Okay, so that finishes that triangle. Angle A, side C, 25.5. Let me fill that in. Okay, so you would think you were done, right? You would totally think you were done. But here's the issue. There is the possibility that this side that was 14 was actually laying this way inside the triangle. See how that could be 14 right there, too? So that forms a totally different triangle. Well, sort of different triangle. So in that case, let me draw the orange version of the triangle here. I didn't do a very good job, but we'll go with it. So in that case, B is still 33, that was given. Side A is still 23, that was given. And side B is still 14, that was given. But now we're doing this triangle instead of the blue triangle. So this is what they call the ambiguous case. So now we have another scenario. So I got to set it all up again. I got to say A, B, and C. I've still been given B is 33 degrees and side B is 14. But I don't know side A. Oh no, wait a second. I do know side A. That was my 23. I don't know side C. So I still have the same three pieces of given information as I did for the problem above, but I laid that side differently to create this obtuse triangle. So the good news is that there's a relationship between the first angle A that we found and the second angle A. All you have to do is take the first angle A and subtract it from 180. So we're going to take 180 and we're going to subtract the first angle A that we found, which was 63.5 degrees. So if we subtract that, that's going to give us our new angle A. So that one turns out to be 116.5 degrees. So we put 116.5 degrees. We don't really have to do another calculation. Then we subtract and we get 30.5 for angle C because we just subtract from 180. And so I really just have to do one more mathematical law of sines calculation. So this time I'm going to say sine of 33 degrees over 14, same ratio, equals the sine of 30.5 degrees over side C, because I'm still trying to solve for that last side, side C. And when you do that, I'll just go ahead and cross multiply and do all the math really quickly for you. It turns out to be C is approximately 13.0. So we get 13.0 for that. So this is the ambiguous case. The ambiguous case is where you can lay that second side in two different ways, and so you get two different triangles, and both of them are correct until you have to do the problem twice. So there's one of those in your homework, and I will work it out and show you the work. I will do the homework and post an answer key. All right, last example. It's a lot of talking today. I'm sorry about that. Okay, so remember the formula for area of a triangle that you learned in geometry? You probably learned it even before then. Formula said to find the area of a triangle, it's 1/2 the base times the height. This side is what we usually call the base, and the height is a perpendicular that goes from the highest point of the triangle down to that base. So 1/2 base times height. And that's a great formula to use if you happen to know the base, one of the sides, and the height to that side. But it turns out that there's a trig way of finding the area of a triangle too. And so take that same triangle, label it the way we do in trig. So this would be side A, this would be side B, this would be side C, across from each of the angles that are labeled with a capital letter. In trig, since we don't know the height of the triangle, we use trigonometry to find the height of the triangle. It's still 1/2 base, But then instead of height, right here, we put a trigonometric expression. And so just depending which one of your sides you're calling the base, if it's B that you're calling the base, then it's going to be C sine of A that's going to be your height. If it's side A that's going to be your base, then it's going to be C sine of B. And if it's going to be side C, that it's going to be your, I think I did this wrong. Hold on. AC sine of B, AB sine of C. Yep, I just about wrote this last one wrong. This one's going to be 1/2 BC AC AB sine of C. There we go. So basically the two sides, and then you use the angle that is missing, that is not one of the sides, to find the area. So really easy to do. I'll do an example of that really quickly. They're all three really the same formula. So let's say you had a triangle that looked like this. And let's say that you knew that this angle right here was 36 degrees, and you knew that this side was 7 inches and this side was 10 inches, and you wanted to find the area of the triangle. So it's really easy. It's just area equals 1/2 the two sides, and then it always has to be the angle that's in between them. So I guess technically it's side angle side if you want to use geometry terminology. So area equals 1/2 7 times 10. Let's call this B, let's call this C. So we've got side C and we've got side B, and then we use the angle that's in between them, and we say times the sine of 36 degrees. And all you have to do is type all that into your calculator, let your calculator do all the math there, and this is going to turn out to be 20.6 inches squared, because now we're talking about area. So it's an alternative formula for finding the area of a triangle if you don't know the height. You really just basically calculate the height. That's what you're doing when you do the little sine function. So it works out really nicely. All right, the book assignment is listed. There's only 10 problems, I believe, but they're challenging. So make sure you give them a try, and then you're welcome to look at my work on the answer key. All right, good luck. Have a good week. 2 book assignments. Lots to learn this week.